When I started actually conducting what I would call formal research in aquatic sciences, I was very much drawn to recovery of watersheds. So mostly from the perspective of fisheries. So areas that had lost fisheries, how could those be recovered? When I first got to West Virginia, one of the first places I visited was the Upper Shavers Fork. And you can think of that as anywhere from Elkins upstream. It's a remarkable place. Brook trout still thrive up there, but they are much reduced. And I spent over a decade trying to figure out what to do where and how best to do it. And we spent the next decade actually doing that and then looking and seeing what has come from it. So 20 years ago, of course, we knew about climate change. We were seeing it in the global climate, but we weren't necessarily seeing it on the ground in a specific place 20 years ago. That has changed. Over the last 5 or 6 years, we are beginning to actually see the consequences of climate change on the rivers. So 20 years ago when I started my work, it was with an eye towards climate change, but it wasn't at the forefront. Now everything we do has to be viewed through the lens of climate change and what the consequences of what we do now are in the future and how climate change will alter that. The work we're doing in Shavers Fork is building resilience to climate change. And what do I mean by that? Well, we know it's going to be warmer up there to some degree, and so we build in opportunities for refuge from warm water during low flow periods. We build that intentionally in. We know that they're going to have to be more mobile because of higher flows, lower flows, higher temperatures. So we replace culverts and barriers to movement. We do all of these things to increase their capacity to essentially evolve at that scale as the climate changes. The big question that we have with regard to climate change, however, is just how extreme it's going to be.